Recording 3 rolling. You guys got your lab data. So you guys should have at least like 5 different data points, right? I know I only have 3 lists on the table just because I ran out of paper. Just try to cover everything in these quadrants, but you guys have at least 5 different data points. Right. So yeah, my last class kind of ran out of time for this just because of that fire drill. But here's what we're doing tomorrow, so you can kind of get a head start with this. See how every single one of these has a title: M versus T, X versus T, V versus T, V versus X. So something versus something. Hey, you guys know from an algebra class like Y versus X? Could you guys graph that? Could you guys graph your data? Here, let's do it for like math versus time. Right. That's going to be, oh, you know what? Maybe I'll do 4 graphs, one for each of these quadrants. So I'll have the graphs line up with the tables. Now, you're going to do either 1 or 2 graphs per lab set, depending on which set you have. That's what makes sense tomorrow. So tomorrow, when you guys come in, I'm gonna have you guys volunteer your data. Need 1 example of each one of these quadrants, and then I will pop those numbers into an Excel page. I have it pre-programmed to make these graphs. But you guys can get a head start here. So M versus T. So you're gonna have mass of the car in grams here, or maybe you did kilograms, but versus time to roll down in seconds, controlling for the angle and also controlling for the displacement of the car rolled. Okay? And then you can plot your point. So however much time it take 1, 2, 3, 4, 5 seconds. 0, 1, 2, 3, 4. Like how much time it take, and then what were the masses of the cars? Maybe the cars' masses. Just as an example, maybe like 100, 200, 300, 400, 500 grams. Maybe the heaviest car you had was 500 grams when you tape it on the lab weights. Okay, so I'm just picking up some example numbers. Maybe you went heavier than that. Okay? But then you guys have the space could carry all those data points. So for example, what if you had a 300-gram car and it took 4 seconds to roll? Okay? So you put a point right there, okay? And then you plot all the points. What if you had, so that's if you had the spades. What if you had the diamond? That'd be displacement versus time. So you put displacement in centimeters on this side. Yeah, thank you. And then time in seconds on this axis. The same thing. Scale it 1, 2. I'm just giving example numbers. It probably didn't take 5 seconds to roll all the way to the bottom. So, scale it exactly like that. But you guys get the idea. Take your biggest time value and then scale it accordingly. If your biggest time value is 2 seconds, maybe like a half, 1, 1.5, 2. And then different displacements. Well, I know that incline goes up to what, 227 centimeters, I think it is. So maybe you can do like 50, 100, 150, 200, something like that, right? 0, 50 centimeters, 100 centimeters, 150 centimeters, 200 centimeters. Okay. And then now all your data can fit in that space. Okay. Do you guys think the longer the distances you had, the more time it would take to roll? Right? I wonder what that relationship is going to look like. Is it going to be a linear relationship? Is it going to be some kind of curvy looking relationship? Hey, let's do a quick hypothesis, or maybe you know the answer because maybe you did this lab and you have the data and you already know how to interpret this. Let's just do a yes or no hypothesis. How many guys think that this should be a linear graph? And what that would mean is that if you like double the distance, it should take double the time. How many guys think it would be a linear relationship for this one? Oh yeah, you said. Oh, hold on. Let me pause this real fast here. Resume. Okay. How many guys think if you triple the time, or sorry, triple the distance, it would also triple the time to roll down? How many guys think that? All right. So that's just the hypothesis floating around. That may or may not be the case. We'll find out tomorrow. Okay. How about if you had the hearts, V versus T? So V versus T. So you had different velocities in meters per second because remember this tool was directly measuring meters per second, right? Probably went like 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5 meters per second. Okay? And how much time did that take to roll in seconds? Maybe like 0, 1, 2, 3, or something like that, right? Okay, and then the last one was V versus X. Okay. I'll tell you guys what, just thinking ahead of the next few weeks. V versus T is going to be a really important graph. You'll see that all over the place. V versus X is kind of an oddball graph. You'll hardly ever see it, but there is a relationship here. And so some of you guys have the data and you'll see how this works out. But I guess if you focus your attention on memorizing any one particular graph, V versus T is a really good one. Even X versus T, you'll see quite a bit. V versus X, you'll hardly ever see this one. Okay. So velocity meters per second as a function of the rolling distance. Maybe you did centimeters, for example, centimeters, right? So this could go up to what? 100, 200, 0, 100, 200 centimeters, right? And then what were the directly recorded speeds on this tool right here? Maybe like 1, 2, 3, 4, 5 meters per second. Okay. All right. Now, those are the main graphs. We're actually going to do a couple of extra graphs too. Remember, some of you guys, I had you guys square the time for the diamonds or square the speed for the clubs. So we're going to do an additional 2 graphs, but those get you guys kick-started. So if you guys are trying to construct your very first graph, then you have the data, you can put those together right there. Any questions so far? All right, so bell's about to ring on us. We'll call that a pause point. Tomorrow, get the data, pop it in Excel, finish those graphs, and then we'll construct those kinematic equations. Oh yeah.